Chapter 5. Acids, Bases and Salts. You will learn acids, bases and salts, properties of acids, bases and salts, indicators, acid rain. We use a number of substances in our routine life such as sugar, curd, common salt, amla, lemon and vinegar. Different substances have different taste. They can be sour, bitter, salty and sweet, etc. Items such as orange juice, lemon juice, raw mango, etc. are acidic. Baking soda is bitter in taste. Substances which are bitter in taste and soapy in nature are called bases. There are some substances which are neither acidic nor basic. They are said to be neutral. There are special types of substances which can be used to test the nature of a given substance. They help you identify whether a substance is acidic, basic or neutral. Such substances are called indicators. Indicator. Substances which are used to indicate the nature of substances. The indicator change their color when added to a solution containing acid or base. Examples of indicators are China rose, turmeric, phenolphthalein and paper litmus. Indicators of acid and bases. Indicators: natural, turmeric, litmus, red cabbage, synthetic, phenolphthalein, methyl orange, olfactory, onion juice, vanilla essence. Natural indicators. Natural substances such as flowers, stems and leaves are used to prepare natural indicators. Examples are 1. Flowers, China rose, rose. 2. Roots, beetroot. 3. Stems, turmeric. 4. Leaves, red cabbage. A very commonly used indicator is litmus. Litmus is obtained from lichen plant. A solution of litmus is prepared from it. It turns red in presence of base and blue in presence of acids. Papers are dipped in this solution to prepare litmus papers. If flowers are used as indicators, solution of such indicators is prepared by boiling colored parts of the plants. Example, boiling petals in water for some times and straining out the petals. This solution gives different color in acidic and basic solutions. Onion juice too acts as an indicator. It changes to deep red with acid, to purple with neutrals and to green and yellow with bases. Red cabbage juice also shows similar color changes. Fascinating fact: turmeric is also a natural indicator. To prepare turmeric indicator, take a spoon of turmeric powder, add a little water and make a paste. Apply the turmeric paste on filter paper and let it dry. After drying, cut thin strips of the yellow paper. Put a drop of soap solution on the strip of turmeric paper. Observe what happens. Now take another strip and add a few drops of vinegar on it. Again observe what happens. Vinegar is acidic and soapy solution is basic in nature. Based on your observations, can you now tell how turmeric paper is used to identify an acid or base? There are some indicators which are prepared in laboratories. They are chemical in nature. The most commonly used indicators are phenolphthalein and methyl orange. The color change brought about by these indicators is as under. Indicator: phenolphthalein, acid, colorless, base, pink. Methyl orange, pink, acid, yellow, base. Real life connect. You must have often heard the word acidity with reference to digestion. Our stomach produces acid called hydrochloric acid. This acid helps in digestion of food and also kills the germs present in it. When the amount of acid becomes more in the stomach, it acts on the inner lining of the stomach, which results in burning sensation in the stomach as well as stomach ache. These symptoms are of acidity. You must have heard of tablets called antacids or antacids. Ask your parents to show some antacid tablets or liquid if you have it at home. You may even be able to see it in the school clinic. Try to read the ingredients. These ingredients are basic in nature. These medicines help in reducing the acid content in the stomach. Acid. An acid is a chemical which tastes sour and turns litmus paper red. It may occur naturally in flowers, vegetables and fruits, or it can be made artificially in a laboratory. Classification of acids. Natural acids. Some acids occur naturally in substances. These substances will typically have a sour taste. The examples are given in the table below. Acidic substance, name of acid present in it. Vinegar, acetic acid. Lemon, orange, citric acid. Curd, yogurt, lactic acid. Spinach, oxalic acid. Unripe mango, tamarind, tartaric acid. Mineral acids. Acids which are inorganic in nature are called mineral acids. They are chemicals and can be prepared in laboratories. The most commonly used mineral acids are hydrochloric acid, sulfuric acid and nitric acid. Mineral acids can be dilute or concentrated. These acids are soluble in water. If the content of acid is more in water, they are called concentrated acids. But if little acid is dissolved in large amount of water, they are called dilute acids. Can you tell which acid is less dangerous, dilute or concentrated? Why? Properties of acid. 1. Acid turns blue litmus red. 2. Acids are sour in taste. 3. Acids are corrosive in nature. Strong acids can destroy paper, cloth or wood. Acids also corrode metals such as iron and aluminium. Therefore, they are not stored in metal containers. Glass containers are used for strong acids. 4. All acidic solutions conduct electricity. 5. Acids are soluble in water. When water is added to a concentrated acid, it dilutes the acid. Always remember that to dilute acids, as a rule, always add the acid slowly into the water. Never add water to a concentrated acid. When acid mixes with water, lot of heat is produced. 6. Acids can be strong or weak in nature. For example, hydrochloric acid is strong and demonstrates its corrosive properties very strongly. On the other hand, acetic acid is a weak acid and is relatively very mildly corrosive. Acids found in curd, fruits and other food products are weak acids. Strong acids, weak acids. Hydrochloric acid, sulfuric acid, nitric acid and phosphoric acid. Carbonic acid, lactic acid, acetic acid, tannic acid and citric acid. 8. Acid reacts with metal to form hydrogen and salt. Acid plus metal leads to salt plus hydrogen. Here, the substance zinc sulfate is a neutral substance and is referred as salt. It is different from your common table salt. Real life connect. Take some vinegar in a test tube. First, dip a red litmus paper and then dip a blue litmus paper in it. Which paper showed color change? What does this test tell you? Remember, vinegar is acidic in nature. Wonder why? Have you ever wondered why your mother uses acid to clean bathrooms? This is because the corrosive nature of the acids removes stubborn stains from the floor and also kills germs. Use of acids. Acids are generally used in industries for making other chemicals. Use of some acids are given below. Hydrochloric acid, HCl. 1. It is produced in stomach and it helps in digestion of food. 2. It is used in the preparation of cleaning liquid. 3. It is used for the manufacture of chlorine. 4. It is very useful in refining process of common salt. 5. It is also used for the preparation of aqua regia, which can dissolve noble metals like gold and platinum. Aqua regia consists of 3 parts of hydrochloric acid and 1 part of nitric acid. Sulfuric acid H2SO4. It is used in car and inverter batteries and in the manufacture of fertilizers like ammonium sulfate. 2. It is very important in the field of chemical industry and hence it is called the king of chemicals. Nitric acid HNO3. 1. It is used to make explosives like nitroglycerin and trinitrotoluene. TNT. It is also used in the manufacture of artificial silk, synthetic dyes and fertilizers. Acetic acid CH3COOH. 1. It is a very weak acid. It is widely used as a preservative. Diluted acid is commonly called vinegar. Vinegar is used in food items to ensure flavor. Carbonic acid HCO3. 1. It is used in the preparation of aerated drinks like cola. Bases. A base is a chemical which tastes bitter, is soapy to touch and turns red litmus paper blue. Base which are soluble in water is called alkali. Types of bases. Strong bases. A strong base is a base which separates into its components to a very large extent when dissolved in water. Sodium hydroxide or potassium hydroxides are very strong bases. Weak bases. A weak base separates into its components to a very less extent when dissolved in water. Magnesium hydroxide, copper hydroxide and ammonium hydroxide are weak bases. Properties of bases. Some of the characteristics properties are given below. 1. Bases turn red litmus blue. 2. They taste bitter and are slippery to touch. 3. Bases react with acids to produce salt and water. Acid, hydrochloric acid plus base, sodium hydroxide gives salt, sodium chloride plus water. Some bases dissolve in water. Some bases are soluble in water and such bases are called alkalis. For example, sodium hydroxide and potassium hydroxide are alkalis because they are soluble in water. Bases that are insoluble in water are not alkalis. Therefore, all alkalis are bases, but all bases are not alkalis. Some bases are corrosive. Some strong bases are corrosive in nature and damage living tissue. Usually, bases do not react with metals and their reaction is very complex. Uses of bases. We use many bases in our daily life. Bases are used extensively in industries for a variety of purposes. Sodium hydroxide, NaOH. 1. It is used into manufacture of paper, textiles and detergents. 2. In homes, it is occasionally used to unblock drains. 3. It is used in the manufacture of soaps and detergents. Calcium hydroxide, CaOH2. 1. It is used to neutralize the acidity in soil. 2. It is an ingredient in whitewash and mortar. 3. It is used in the preparation of dry mixes for painting and decorating. Magnesium hydroxide, MgOH2. It is used as an antacid or a laxative. It helps to correct excess acidity in the stomach. Ammonium hydroxide, NHOH. 1. To manufacture fertilizer such as ammonium nitrate. 2. To manufacture nylons, plastics, dyes, etc. 3. As ink remover to remove ink spots from cloths. Other uses. Sodium carbonate is used as washing soda and sodium hydrogen carbonate as baking soda. Baking soda is also used to treat ant stings. When an ant stings, it injects formic acid into the skin. This irritates the skin. Baking soda or calamine solution, zinc carbonate, is used to neutralize the acid and provide relief. Differences between acids and bases. Properties Acids, bases. 1. Taste. Sour taste, bitter taste. 2. Feel. Corrosive and give burning sensation. Soapy to touch and strong bases are corrosive. Litmus test. Turn blue litmus into red. Turn red litmus into blue. Dissolved in water. Acids are soluble in water. Only some bases are soluble in water. Action with metals. Give hydrogen gas. Generally to not react. Salts. Since acids and bases are opposite in nature, their effect is cancelled and the resulting mixture is neutral, neither acidic nor basic. Such neutral substances which are formed by combining acids and bases are called salts, and the process or reaction of combining acid and base to obtain salt is called neutralization. So now, salt can be defined as a substance formed due to neutralization reaction between acids and bases. Salt are neutral in nature. Remember, all salts are neutral, but all neutral substances need not be salts. Neutralization reaction is the reaction in which acids and bases react with each other to yield salt and water. Acid, HCl, plus base NaOH gives salt NaCl plus water H2O. Hydrochloric acid, sodium hydroxide and sodium chloride, common salt. Use of salts. Salts form an important component of our daily life. The human body needs certain salts. Many medicines are made up of water-soluble salts. Plants also need a variety of mineral salts for better growth. Fertilizers such as ammonium sulfate and potassium nitrate are water-soluble salts which replenish the fertility of soil. Sodium chloride, NaCl. 1. It is the common salt or table salt used in food to enhance taste. 2. It is a good preservative for preserving pickles. 3. It is also used for producing freezing mixture by adding it to ice. 4. It finds extensive use in the manufacture of pulp and paper and in setting dyes in textiles and fabrics. 5. It is also used in making soaps, detergents and other cleaning agents. Sodium carbonate, Na2CO3. 1. It is used in manufacture of glass. 2. It is also known as washing soda since it is used for softening hard water to enhance the capacity of detergents. Copper sulfate, CuSO4. 1. It is used in the preparation of fungicides. 2. It is used in the dyeing industry and also as a wood preservative. Sodium bicarbonate, NaHCO3. 1. It is also known as baking soda and is used for baking cakes and breads. 2. It is used in some aerated drinks. Drinks having CO2 dissolved in it. For example, Pepsi, Coke. 3. It is also useful in the preparation of many medicines and even in fire extinguishers. Properties of salts. 1. Melting point and boiling point of salts are very high. 2. Salts are mostly soluble in water except for a few like calcium sulfate and silver chloride. 3. Several salts may be in crystal form with water molecules attached to the particles of salts. The water molecules are called water of crystallization and such salts are called hydrated salts. For example, magnesium sulfate has 7 molecules of water for each magnesium sulfate molecule. The 7 water molecules form the water of crystallization and this salt is called as hydrated magnesium sulfate. 4. Salts which lose their water of crystallization are called anhydrous salt, meaning without water. Acid rain. With increasing industrialization, we have huge number of factories and industries which give out gases such as sulfur dioxide in the air. Also, increasing number of vehicles has ensured that the level of carbon dioxide has drastically increased in the atmosphere due to the burning of petrol and diesel. These gases mix with the moisture in the atmosphere. When they mix, they form acid. So when it rains, the rain contains a high level of acid formed by harmful gases. Such rainfall, which has high level of acid content due to pollutant gases like sulfur and carbon dioxide, is called acid rain. In our country, the World Heritage Taj Mahal also faces a huge threat from acid rain. It has started losing its color and the artistic sculpture is getting damaged due to acid rain. The primary cause is the refinery situated at a distance from Taj Mahal, which emits pollutant gases in the air. Subject integration. Bases are mostly used in chemical industry, such as fertilizers. Fertilizers are most important plant nutrients. Without nutrients, the crops cannot grow. For example, ammonia, which is used for increasing the level of pH in the soil. Skills and values. The study of this chapter provides a basic understanding of chemistry. They are enabling their interests and perceptions in their laboratory experiences. They also gain a knowledge about the uses of acid, base, and salt in their daily life. Key points. Indicator, substance which helps in identifying the acidic or basic nature of the substance. Acids, substances which are sour, corrosive in nature and which turn blue litmus red. Bases, substances which are bitter, soapy to touch and which turn red litmus blue. Salts, these are substances formed when acid and base react together in the neutralization reaction. Neutralization, the process in which acids are made to react with bases so that they yield salt and water. Rapid review. 1. Acids turn blue litmus red and bases turn red litmus blue. 2. Acids are sour and corrosive in nature. 3. Bases are bitter in taste and feel soapy to touch. 4. Substances are bitter in taste and feel soapy on touching are known as bases. 5. To check whether substances are acidic or basic, we use substance called indicator. Example, phenolphthalein. 6. Natural indicators. Flowers, China rose, roots, beetroot, stems, turmeric, and leaves, red cabbage. Litmus are natural, while phenolphthalein and methyl orange are chemical indicators used in laboratory. 7. Salt. Substances formed by reaction between acids and bases are called salts. Salts are neutral in nature. They are neither acidic nor basic.